Hey there, science fans. It's your old pal, Tinkleton, and I'm bursting with excitement to talk about something truly awesome: chemical reactions. They're happening all around us, constantly transforming our world. From the rust on your bike to the baking soda volcano you made in elementary school, it's all thanks to the magic of chemistry. Think of it this way. Imagine you're building with Legos. You've got all these different bricks, right? Those are your reactants. Now, when you snap those bricks together in a new way, you create something totally different. A spaceship, a robot, maybe even a crazy cool castle. Those are your products. So buckle up, science explorers. We're about to journey into the heart of matter and uncover the secrets of chemical reactions. Let's kick things off with a bang, or should I say, that's right, we're talking about combustion reactions. These are the reactions that make fire possible. Combustion happens when a substance like wood or gasoline gets cozy with oxygen and releases a whole bunch of energy in the form of heat and light. Think about what happens when you light a candle. The wax reacts with the oxygen in the air, producing those mesmerizing flames and some heat. But it's not just about candles and campfires. Combustion powers our cars and helps generate electricity in power plants. Here's a simple equation for methane combustion. CH4 plus 2O2 gives us CO2 plus 2H2O plus energy. That's methane gas reacting with oxygen to give us carbon dioxide, water, and a whole lot of energy. Pretty neat, huh? Now that we've tackled the explosiveness of combustion, let's explore combination reactions, where two or more substances join forces to form a single, brand new substance. One of the most common examples is the formation of water. It all starts with two simple elements, hydrogen and oxygen. When these two gases get together, they react to form H2O, which is the chemical formula for water. It's like a match made in chemical heaven. Combination reactions are happening all the time, everywhere, from the formation of rust on your bike to the creation of new compounds in a chemistry lab. These reactions are constantly shaping our world. Hold on to your lab coats, everyone, because we're about to dive into decomposition reactions. These reactions are like the opposite of combination reactions. Instead of two or more substances coming together, we have one substance breaking down into two or more simpler substances. Think about what happens when you heat up sugar. It caramelizes. But did you know that's a decomposition reaction in action? When heated, sugar breaks down into caramel and water. Another example is the decomposition of hydrogen peroxide. When exposed to light or air, it breaks down into water and oxygen gas. And that, my friends, is why hydrogen peroxide is stored in those dark brown bottles. Pretty sweet, right? Get ready for some chemical magic because we're talking about precipitation reactions. These reactions are like a cloudy mystery where two clear solutions are mixed together and suddenly, a solid appears out of nowhere. When certain solutions are mixed, the ions in those solutions can react to form an insoluble solid called a precipitate. One classic example is the reaction between silver nitrate and sodium chloride, forming a white precipitate called silver chloride, which falls to the bottom of the beaker like a chemical snowfall. Fasten your seatbelts, science fans, because we're about to enter the exciting world of acids and bases with neutralization reactions. Acids and bases are like the yin and yang of chemistry. They're opposites that balance each other out. When they react, they neutralize each other's properties, producing salt and water in the process. Think about it this way. Acids are those sour substances that make lemons pucker and give vinegar its tang. Bases, on the other hand, are slippery to the touch and can be found in things like soap and baking soda. When an acid and a base meet, they neutralize each other, creating a solution that's neither acidic nor basic. It's neutral. One of the most common examples is the reaction between hydrochloric acid and sodium hydroxide, producing sodium chloride, table salt, and water. Get ready for some chemical competition because we're talking about displacement reactions. These reactions are all about one element getting a little bit jealous and deciding to replace another element in a compound. To understand displacement reactions, we need to talk about the reactivity series. This series ranks elements based on how eager they are to react. One classic example is the reaction between zinc and copper sulfate. Zinc is more reactive than copper, so when you add zinc to a copper sulfate solution, the zinc displaces the copper, forming zinc sulfate and leaving copper all by itself. It's like a game of chemical musical chairs where only the most reactive element gets a seat. Hold on to your Erlenmeyer flasks, science buffs, because we're about to waltz into the world of double displacement reactions. These reactions are like a chemical square dance where two compounds decide to swap partners, forming two brand new compounds in the process. Imagine two couples at a dance. Suddenly the music changes and they decide to switch partners. That's kind of what happens in a double displacement reaction. The positive and negative ions in two different compounds switch places, creating two new compounds. One common example is the reaction between barium chloride and sodium sulfate, forming a white precipitate called barium sulfate, while the sodium ions and chloride ions stay in solution. Well, there you have it, science superstars. We've explored the amazing world of chemical reactions, from the fiery intensity of combustion to the delicate dance of double displacement. We've seen how these reactions shape our world, from the air we breathe to the food we eat. But our journey doesn't end here. Chemistry is a vast and exciting field with endless possibilities, so keep exploring, keep asking questions, and most importantly, keep that love of science alive. Remember, the world is your laboratory, and every day is a chance to discover something new. Until next time, stay curious.